In this video I'm going to show you how to run correlation analysis in SPSS. With correlation analysis we can determine whether two variables have positive relationship or negative relationship or neutral relationship with each other. So let's run the correlation analysis. This is my data file and this is my data file since I have started to post data analysis videos on YouTube. Here is y is my dependent variable. x1, x2, x3 are the three independent variables, but in correlation analysis you don't need to consider which variable is dependent or which variable is independent, because in correlation analysis you are just looking for whether two variables have positive, negative or neutral relationship with each other. However, to run the correlation analysis we have to go to analyze and focus on correlate and then click on bivariate. All the variables of your model will be found listed on the left side, and you have to pass them those variables on the right side, and you can check the correlation between two variables just like y and x1. You can skip these two variables if you don't want them. But in this case, in this model, I'm considering all the variables to look at their correlation, to look at their relationship with each other. And the next step is you have to determine the level of significance in your correlation analysis. The level of significance can be 1% or 5%. If you consider 1%, then you will click one tilt, or if you are considering 5%, then you will click on two tilt. In this model, I'm considering 5% level of significance, so two tilt is okay for me, and then click on OK. This is the outcome, and now I have to interpret it, but the fonts are smaller, so I'm just copying it and pasting it in the Word file. So larger font will appear, and bring it in the middle. Before interpreting, we have to know some rules and regulations. Those are required to interpret. We will consider two values from this table. First one is Pearson correlation, and second one is significance of the Pearson correlation. First one will tell you whether the two variables have positive relation or negative relation with each other, and how much strong that relationship. And the second one, whether their relationship is statistically significant or not. And also Pearson correlation value has a range of -1 to +1. -1 indicates a strong negative relation and +1 indicates a strong positive relation. And here in this table is a cross-section table, because you will find all the variables are arranged horizontally and vertically. So let's interpret this table. First one is y the same variable, so we are not considering this portion. The next one is y and x1. Y and x1. So this portion shows the correlation between y and x1. Here we see the Pearson correlation 0.923, which is very close to +1. It indicates y and x1 are sharing a strong positive correlation with each other. On the other hand, we can say if y increases 100, x1 will increase by 92.3. And from the significance or p-value, we see this relationship or this correlation is statistically significant. So the final conclusion is that y and x1 are correlated and their relationship is strongly positive correlation, and their relationship is also statistically significant. Then consider y and x2. From here we see the Pearson correlation is -0.924, which is very close to -1. It indicates a strong negative correlation between y and x2. Otherwise, we can say if y increases by 100, x2 will decrease by 92.4. And from the significance or p-value, we see this strong negative correlation is statistically significant. Then we can consider y and x3. Here we see the Pearson correlation shows a strong positive correlation between y and x3. We can say with the increase of 100 of y, x3 will increase 91.1. And the significance or p-value shows y and x3 also have a statistically significant correlation. In this way, we can determine the correlation among other variables in your model. Just like if we want to look at the correlation between x2 and x3, then this correlation statistics show that the Pearson correlation is -0.847, means that with the increase of 100 of x2, x3 will decrease by 84.7. And their relationship is also significant as the p-value shows 0.002, which is less than 0.05. So in this way you can determine the relationship, the nature of the relationship among the variables of your model. And this is the main content of this video. And if you have any question, feel free to ask in the comment section. And finally, thanks for watching.